Hello everyone, welcome back to the channel. In this video we are going to solve this numerical problem related to the topic rotational dynamics. We are asked to find the angular velocity gained by a wheel in 4 seconds and kinetic energy gained after 20 revolutions. We are also given a torque of 500 Newton meter is turning the wheel about its center, and the moment of inertia about that axis is also given, which is 100 kg meter square. So let's solve this. At first, let's write the given things. Given torque tau is 500 Newton meter. Moment of inertia of the wheel I is given to be 100 kg meter square. Okay, and we need to find out angular velocity gained in 4 seconds. That means initial angular velocity omega naught is 0, assuming the wheel is starting to rotate from the rest position. Okay, so given in time t equals to 4 seconds, angular velocity gained will be omega minus omega naught, but omega naught is 0, so equals to omega equals to what? We know omega equals to omega naught plus alpha t, right? As tau equals to I alpha, or alpha equals to tau by I. Tau, that is torque, is given to be 500, I is given to be 100, so this is 5 radian per second square. This is angular acceleration, that's why radian per second square is the unit. Using alpha equals to 5 in equation first, omega equals to alpha t equals to 5 into 4 equals to 20 radian per second. That is angular velocity gained by the wheel in 4 seconds is how much? 20 radian per second. Now we also have to find out kinetic energy gained after 20 revolutions, right? Whenever there is revolutions, it means we need to talk about angular displacement as well. For one revolution of wheel, right, angular displacement is theta. Angular displacement is 2 pi. For 20 revolutions of wheel, angular displacement theta will be 2 pi into 20 radian, right? Now what we have to find? We need to find out the angular velocity after 20 revolutions of wheel. And why we need to find out the angular velocity is because kinetic energy formula is k equals to half I omega square, right? There is the necessity of velocity, angular velocity. Therefore, angular velocity of the wheel after 20 revolution omega equals to what? We know omega square equals to omega naught square plus 2 alpha theta, right? Or omega square equals to omega naught is 0, right? So 2 alpha is 5, we have already found out above, we have already calculated this. Theta is 2 pi into 20, so this comes out to be how much? 5 into 10, it is 400 pi. Let's not write the unit here, it is actually radian square seconds per second square, but let's leave it as it is. Omega square is 400 pi. This is equation second. So why we are leaving it as omega square? Because our formula for kinetic energy is half I omega square, right? No need to further evaluate it. Therefore, kinetic energy gained by the wheel after 20 revolution is equal to, so after 20 revolution, this is the kinetic energy. Initially it's 0 because omega naught is 0, right? Or you can also show like this, right? Omega naught is 0, that's why this term is 0. Now half I is 100, omega square we found out to be 400 pi, right? That's why we would get 20,000 pi joule. This is the kinetic energy gained. Okay, therefore kinetic energy gained by the wheel after 20 revolution is 20,000 pi joule. If you use a calculator, this would come out to be 62,800 joules of energy. So this is the solution of this numerical. If you have any confusion, please comment below, and also do not forget to subscribe us. Thank you.